I'm on page 183. Okay? Remember, 0 through 6, possible home mortgage closings. Probabilities attached haven't changed. They're the same as they just were. So, the probability, this is x times the probability of x. So 0, if this is the observation x, 0 home mortgages times the probability, 10% chance of that happening. X times the probability x gives you a 0. Okay? Now, and again, this is what we looked at last section. Gives us, when we sum all these up, it gives us an expected value of 2.8. Now, I take that same observation, 0, I subtract 2.8. It's written on page 183 if you follow along. You square that value times the probability, which was 0.1, and you end up with 0.784. Okay? If that was too fast for you, take a second and look on page 183. Now again, my observation is now 1. You subtract 2.8. 1 minus 2.8 is negative 1.8. Negative 1.8 squared times the probability, 0.1, gives you 0.324. Okay? 2 minus 2.8, negative 0.8 squared times the probability, 0.4, gives you 0.128. So on and so forth throughout observations 1 through 6. Then, look, I have sigma. Sigma means to add, so I'm adding this list of numbers. So 0.78 plus 0.32 plus 0.128 plus so on and so forth. And this gives me a variance of 2.46. And I want this to be in 2 decimal places at least. So if these are given in 3 decimal places, you can round to 2 decimal places. If they're given in 4 decimal places, you can round to 3 decimal places, and so on and so forth. The standard deviation is very simple to calculate once we have the variance, because the standard deviation, which is listed as sigma, is just the square root of the variance, 2.46. Or in this case, 1.57. Okay? And that's given on page 183 as well. Now, I want you to practice in this section with 5.1, 5.2, and 5.3. Okay? This is just good practice for variance and standard deviation. The next section, 5.2, talks about covariance and its applications in finance. Now, covariance is a very tedious equation, and we will not calculate this by hand. I do expect you to get the definition. A covariance is the measure of strength of the relationships of 2 discrete variables. I'm taking this directly off the page at the bottom of 184, okay, in the section labeled covariance. Okay? It has applications in finance because we're looking at the relationship between 2 discrete variables. Now, we will not calculate these by hand, and I don't want you to. I want you to know that if there's a positive covariance, it means the 2 variables have a positive relationship. If there's a 0, it means the 2 variables are independent. And if there's a negative covariance, it means there's a negative relationship between the 2 variables. It's pretty intuitive, but Excel will always give us the covariance. We, in practice, would never calculate a covariance by hand, so I don't expect you to. Combinations. Combinations are essential for grasping the concept of the next probability distribution we're going to look at. The binomial distribution uses combinations. Now, combinations might look scary, but we use them all the time in our heads. It's not something entirely foreign. It's not a foreign concept because it's pretty intuitive once I explain it. Now, it can look pretty gruesome. N choose X. This is the notation that will represent the fact that we have a combination. Okay? N choose X is written little n, big C, small s, small x, and it's N choose X. Now, we are looking at the way of choosing X objects from a total N objects. Now, what does this mean? Now, your book talks about how can we select 3 students out of 4. How many different ways can we do that? For instance, if we had Vanessa, Stephanie, Richard, and Rick, right? So Vanessa, Stephanie, Richard, and Rick, I'll write it out. Then, and 3 of these students got to go to the moon on a space expedition. Now, how many ways would I have of choosing 3 of them from 4? How many distinct groups would I have? Okay. I could choose Vanessa, Stephanie, and Richard. Or I could choose Stephanie, Richard, and Rick. Or, I'm sure you can see that I could choose Vanessa, Richard, and Rick. And what's my last combination? Rick, Richard, no, Richard, Rick, and Steph. I don't know. There's another. It gets confusing. Okay? It's hard to know how many groups of 3 I can make out of 4. Okay? Sometimes we get lost. So this formula will tell us exactly how many groups of 3 we can make out of 4 without getting our head all confused. Okay? We won't need to underline and try to figure it out. We will know exactly how many distinct groups of 3 we can get from 4. Now I have a question. Is the group Vanessa, Stephanie, and Rick the same as the group Stephanie, Rick, and Vanessa? Yes, right? It doesn't matter who I select first, second, or third. You all get to go to the moon. Okay? So this is good. You all get to go to the moon, and poor Richard got left out of that equation. Right? So Vanessa, Stephanie, and Rick go to the moon. Richard gets left out of that equation. It doesn't matter who gets chosen first, second, or third. Okay? That's a point you need to remember. Now let's step into this formula just a little bit. First notation you need to know is the exclamation point. This exclamation point we call a factorial. Now a factorial is a simple notation to let us know that we are going to be multiplying n times n minus 1 times n minus 2 times ... n minus n plus 1. Okay? Well, that's very confusing until you think about what's our situation. We have 4, right? So what's n? N is 4. N minus 1 is 3. N minus 2 is 2. N minus n is 4 minus 4, 0 plus 1 is 1. So we take from our number n and multiply in descending order, subtracting 1 always, until we get to 1. Okay? We do not do 0. Why don't we add 0 in that list? Well, if we did all this times 0, what would that be? Of course, that would equal 0. So that's why we have this last one, n minus n plus 1, so that we don't multiply a 0 there. So this factorial, n factorial, would be 4 times 3, which is 12, times 2, which is 24, times 1, which is 24. Okay. Okay? Now remember, sometimes it's easier to write out that n is 4, x is 3. So we're choosing 3 objects from 4. So now, 3 factorial times n minus x factorial. Well, let me rewrite this so you don't get lost. So we have 4 factorial over 3 factorial times 1 factorial. This is our n choose x. What's this 3 factorial? Well, that's again 3 times 2 times 1, which equals 6. Okay? And 1 factorial is easy. It's just 1. So now